this short video, we're just going to compare the line of business REA versus the aggregate of all LOBs, and also simulate a composite data set from the composite model. So let's go back to our composite be all, run model good, which I think we need to run it twice. So I guess you can do it from within the MPTF module once you're in it. So load model in new window, load model good. And when we do the forecasting with the right button of our mouse on the forecast dialog box, the first one we do, let's load good combined, and then highlight all the data sets with your shift key, except for now use your control key REA. So we only want to do the forecast for line of business O as in Robert, EA. So now you remove these. You save that as, say, REA combined only. Save. Well, that should be pretty quick. It's only one line of business. And then for the second one, which in this case, for another one, just do good combined. And now let's do the simulations for both. Before we do that, why don't we look at the forecast summaries for both? All, tile vertically, minimize other types. So for where we calculate the aggregate, let's look at REA. Got to find the tab. There it is. And that should correspond to what you have in the other one, which is good number 2, where we only forecast for REA. Now with the right button of your mouse on the PILD dialog box, all, well, let's just look at, say, reserve risk. So reserve, when you're doing the simulation through the reserve part, and similarly reserve when you do it for the aggregate of all the lines of business. Obviously you're doing many more simulations, so it takes a little bit longer. As I've mentioned before, you're simulating about 12 million times from correlated log normals, which is pretty fast. Tile vertically, minimize other types, go to risk capital, graphs, say 95%. Let's look at this graph. The top left one tells you the total risk capital is 4.2 million. And on the other side, risk capital graphs go to 95%. And we're just looking at REA. So it's quite interesting. The risk capital you need for REA is 2.9 million. If that's the only line of business you wrote, and you wouldn't get any credit risk credit diversification, risk credit diversification for writing the other lines. If you're writing the other lines, you need 4.2 million, and how much do you allocate to REA? It's 1.89. So a lot of it you allocate to REA. I guess the other one, you allocate a lot of capital to 1.5, goes to workers' comp. So you get kind of a lot of credit, you get a lot of risk credit diversification. Sort of found it hard to say that. risk credit diversification for writing the R lines of business. Not so much for writing WC, because that's got a huge coefficient of variation, but the other ones really contribute a lot to risk credit diversification. Okay, what I'd like you to do is close the module, which is the second one, number 2. Which this is where you only do the forecast for REA. So you click on the X. And let's also do, suppose you did some reinsurance on the aggregate lines of business, some kind of adverse development cover. So click on REA and OK. So we'll come up with an additional table which will apply to the aggregate of all these lines of business. So now we're kind of saying that if we take out cover, which is 2.3, around 2.3, you won't get exactly the same statistics because it's based on the simulated sample values. 2.3 million in excess of around 24.7 million will reduce the coefficient of variation from 0.9 to 0.7, and the reinsurer would take up a coefficient of variation 1.42. What we'd like to do now is create a report on this. No, we don't want to do a report. A report is actually part of the next study. What I'd like to do now is close a lot of the tables. So why don't we close this one? Close everything that isn't a model display. Is there under test close? Well, you can close. Let's try and close testing windows. See what happens. Haven't tried that for a while. So it just comes up with a regression table. We can minimize that and just go back to NPTF and just open, well, you've got the model display and the residual graph, okay? Now, what we'd like to do is simulate a composite data set from our model. So you go to test, go to simulate composite. I'll wait for you. We're just going to simulate one. We've done this before in another study. So each model has its parameters and process variability. We also have the, if you look at these tabs to the right, we have the correlations, where there's very little process correlation. We simulate one composite data set. It will actually simulate a data set for each line of business. There are 15, and then create the composite data set in the composite triangle group. So with the right button of your mouse, you go to triangle group tab, go be all, and you'll have CDSS sim. If you go to composite data sets and click on CDSS sim, these are, let's maximize this. These are the simulated triangles for the 50 lines of business, 15. Go back to models, click on CDS. Now take model good and put it on CDS sim, drop it on, then go back to CDS, click on the forecast scenario, and let's grab, say, good combined. Let's just take that one and put it on top of CDS sim. Now go back to the, we're looking at composite, forecast on the right, click on models and run model good. Now tile vertically, minimizing, don't tile vertically, click on the model display with the right button of your mouse, select all, and now tile vertically, minimize other types. On each side, let's look at HLFO. So one is simulated. Your simulations might not be identical to mine, but your simulated data sets will have the same kind of trend structure and process variability. Go to PPA, PPA, and so on. Cal versus Cal, and so on. Now, right button of forecast dialog box, select all, load, good combined. Okay. Load, good combined. Okay, which we already did. Now, forecast summaries, tile vertically. Sorry, forecast summaries, right button, select all. I'm not going to sleep. Minimize other types. And actually, I get a 28 million for my simulated versus 24.7. So you'll have to try and find out which data set is the culprit, because my difference, well, it's much less than the standard deviation, but all of a sudden the standard deviation of the aggregate is 4. So I wonder what happened to my simulation. I hope you don't get that kind of result, that in fact in your answer, the only thing that I suspect would have done that is in one of the models there must be a parameter that is insignificant, or it's got a high standard error. And I think that might have been with workers' comp for the real data. If you look at the model display, you can see. So when we simulated, that trend could have been very different, and we are forecasting with that trend. So that's my guess where the culprit, where the actual culprit is. Well, let's check. It's workers' comp on this side, workers' comp on this side. Yeah, you got 4.7 million as a mean versus 2 point, and that's because, and there's a lot of uncertainty, and that's because of that parameter uncertainty. Can't really do much about it because it's only 10 by 10 data. But typically, if you were modeling workers' comp, you'd be using 20 years data or 35 years data, so you won't have this particular phenomena. If we click with the right button of our mouse on the model templates, select all, and run the SGA for each of the data sets in each of the composites, seem to have lost everything. Go to the residual button and click with the right button of your mouse, select all, and now go to tile vertically, minimize other types. Let's go to HO, FO on each side, and you'll see similarities. They look very similar. PPA versus PPA, Cal versus Cal, and so on. Okay, thanks.